Hello, good day, this is Chris G4NAB. I'm about to introduce you to an instructional video on how to get the SvxLink image going with SvxLink version 26. Doesn't seem possible, does it? 26. Never mind. Tobias, you've done a splendid job. Thank you very much indeed for the update, and it works splendidly. Here is an image I have made from the compilation of the SvxLink, so you don't have to. A lot of the complaints I've noticed in various forums, especially from the United States, is that the compilation of SvxLink has been a major put-off to enable someone to experiment with it, which is possibly the reason why that SvxLink appears to be the major competitor in the voice over internet protocol linking throughout the world, which is amazing because I find that the ASL3 software and its repeater configuration even more complicated than SvxLink. I know because I use them both together in the same environment. So what we'll do is explain to you what we have at the moment. What I've done is to pull Tobias's software into my own repo for the moment and make some adjustments to the cmake lists.txt file, which actually builds into a package, a Debian install package that you can run with sudo apt install. So I've done this, and I've done this to a particular image, so it doesn't take up an awful lot of room. It confines itself to the package and its dependencies, plus another few ancillary things like JSON and Python updates, but I've incorporated that all into the same image. And I've also built a dashboard around the SvxLink package to make it so simple as you wonder why you haven't tried it before. This does not preclude you going exploring SvxLink from other sources, and I recommend that you do so, particularly with svxlink.org and for groups.io in the SvxLink section, which is where most of the conversation takes place about the little problems that arise. However, I hope to have covered all of those in this upcoming build. The image is available. I shall put the location in the fields at the bottom of the video when it's completed. However, what we're going to do now is to explain how it works. First of all, there'll be an instructional video on how to install it. This is done with a package called Raspberry Pi Imager. I find that works better than most. I'm using an old version because it has proved to be more stable, and you do not need to unzip the image. It tackles it all itself, and when installed into the SD card of your preferred size, it expands to fill the whole of the filing system. So this can be for anything from an 8 GB SD card upwards. Anything smaller, you'll be fighting a losing battle. What I have done is I built it into a 64-bit image using Debian Bookworm. People will say, why have you not used Trixie? It's because I haven't yet got round to overcoming the issues relating to hotspot creation introduced by NetPlan and Cloud Init, which take control of Network Manager. These can be disabled, but I haven't been able to start the work on creating a Trixie image. So we're sticking with the long-term support that Debian Bookworm gives, and there will be no requirement to change. However, once you've got this image downloaded, follow the instructions on the following clip.
Recording of the SvxLink image to an SD card. In the Raspberry Pi imager, I'm using an older version because it's more stable than the new one, and the new one gets a bit complicated. But I'm making it as simple as I possibly can. There is no filtering. The operating system is the image that I've downloaded. The storage is the generic storage device with the SD card inserted, of course, and we next go to the next stage. Would we like to apply OS customization settings? No, we don't, because it's all built into the SD. Existing data will be raised. Yes, we're happy with that, and it's now writing. It will need my password or fingerprint in this case. Okay, it wants my password today, and off it goes writing. The image itself has been crunched to about the size of 990 megabytes, but will expand to fill available space on a 16, 32, 64-bit card. So don't worry about the size of it. I haven't tried running it in a 4, but they're as rare as rocking horse droppings, so we won't go there.
Okay, you've now got your image installed on the Raspberry Pi. If you've used a Raspberry Pi 02W, you obviously have no network connection, so what you need to do is to use a device to which you can connect to the access point generated by the Raspberry Pi. You will find that as the SSID of hotspot with a capital H or H, just covering all bases there, and the password is password. Once in that you're on your local device, you need to then open up the following URL, and that is svxlink.local:5000, that's 5000 /Wi-Fi. If you can't find that, then try 192.168.50.1:5000 /Wi-Fi. And you end up with a page like this. And this is where we start to introduce our Wi-Fi. So on your device that you're connected to the access point, click on AirScan. Hopefully you're in the same environment where you live, and you'll see that mine is BT-5HCPX2, and you will type that in the SSID field, followed by your access password. Once you've done that, you can click on Add and Connect, and shut down your current device, because your hotspot will now connect to your own home Wi-Fi. And then you can go and do exactly the same thing. You'll type in your svxlink.local:5000 and just leave that as 5000. So we'll do that now, but I've already found my IP address, so we'll ignore that. We're just going to 5000. And this is the start of the dashboard. I'm building my system on an HSR USB device, which is a hotspot radio device which plugs into a Raspberry Pi 2.0. It contains an SA818 device pre-programmed to the frequency that I'm going to be using, and it also contains a modified CM108 device which contains all the codes required for accessing PTT and the squelch. So we're going to use the software called HiDraw and use nothing else in the device. I'll explain as we go. So So we're going to start the startup. Here we go, starting the startup now. Platform detection. It depends what you've installed it on as to what the device will detect. The software is also been updated to build onto a Nano Pi Neo, and the Nano Pi Neo is a tiny device using an H3 processor in exactly the same way with a slightly different operating system, but it will indicate the platform that is supported. As you can see, this platform is supported on a Raspberry Pi, so we continue. And the operating environment is where we will connect. This present image will only support the UK-wide, North America and Australia reflectors. I've built it specifically for these three locations because of the way we allocate the passwords for the reflectors, which we'll see in just a moment. It also at this point gives us the opportunity to select our language. At the moment the only languages supported are English British, English USA and English Australian. They have their own characteristics and the appropriate language skills and accents, of course. Australia is the new one that's got Natasha, who sounds like an Australian air traffic controller. So I'll just show you the next stage. I'm going to click on North America first of all, but we can come back to this screen as we can go back in our operating environments up to the point where we've installed our call sign. The call sign is the only thing we will not be able to change in the duration of the build. So we'll continue. And here we've got the opportunity to select the time zone for the location in which you are. If it's for USA, you will get this large selection here. That includes Canada. I haven't forgotten Canada, but obviously there are various time zones within the Canadian continent. You will have to choose the equivalent in the USA section because I can only remember the two for Canadian Eastern and the Canadian Pacific. So we'll go back and we'll check British Isles. And our options are only one. And we're going to go for United Kingdom and continue. Now, what are we going to do? We're going to build a simplex node. We're not going to build a repeater because the device isn't compatible, and simplex is because we're using a hotspot. And we enter my call sign. G4NAB, here I am. And we now continue. Remember what I said about HiDraw earlier on? We're going to be using HiDraw, where the Squelch and the PTT use a compatible USB HID radio interface. This is the modified CM108. So I'll click the radio button there and ignore everything else. If I were to select on hybrid, then I'd be able to select the Squelch later, but we'll leave it at HiDraw for the moment. The other options for the GPIO line interface is if you built your own interface which relies on a GPIO bus on the Raspberry Pi. If you've built the system onto a Linux PC, the only access you'll have, of course, will be a serial port or a HiDraw card. You can actually plug the HiDraw card into a PC and you'll have the same capabilities. But in case you have a serial device, then you select the serial device designation, which you'll have to pre-check inside your terminal. As you can see, we're not using the terminal at the moment. So we'll continue with HiDraw. Continue. The Squelch method again, I'm going to select HiDraw. However, some devices may find that the HiDraw sense is inverted from active high to active low. We can actually change that in the settings here, but we know that mine is active high, as is the PTT, but there is no option to change that because it's always GPIO 3 in the settings. So we'll continue, ignoring the rest of the system because we are using Hydro. Ignore the rest of the fields. And of course the SA818 has got a built-in CTCSS, so we don't need to select any frequencies. We'll continue. Every radio station requires to send out some period identification. So I've selected here CW at 15-minute intervals and a voice identification on the hour. You can select as many options as you like, but only one. CW settings, where the CW is used as identification, it's set to -10. You can change that, but always have a minus value. The CW pitch, that's the pitch at which we would normally hear CW on the HF bands through a CW filter, set to 650 Hertz. And the speed is 95, which is roughly 10 to 12 characters, words per minute, or 95 characters. We want to increase that just a little bit to 120, which in my opinion is a little better, faster, and doesn't drag. So we'll continue. Courtesy tone, we're going to set that to a Morse K. The beep frequency refers to the single beep option, so you can actually change a beep if you want to select that opportunity. Continue. Modules. Now there are two modules built in to this image. Module SvxLink and module METAR. The module METAR generates airport weather information for your local airport or a selection of airports, depending on how you set it up. I'm going to bypass that section at the moment, but we can come back to it in just a while. But I will show you the METAR information screen. There's the selection of airports that have their identification already installed in the language files. We'll continue. Now we want to connect to a reflector. I don't want to connect to North America, I want to connect to UK wide. Have I got my password ready? If I haven't, I can click on UK wide and generate a password that will be sent to me by email. It may take an hour or two depending on which administrator has picked up the message, but you will be sent a 16-character password to put in the box at the bottom. Now then, I'm going to pause the video momentarily while I put my password in. I've put my password in and I've now moved on to the next screen, which is the setup for dashboard access. Excuse me. You can create your own username and your own password. For the sake of simplicity on my system here, I'll use admin and admin and select continue. I've checked my passwords, fine, okay, I'll close that. And I can now review what I'm setting it up at. The environment, the node, the interface, the squelch, identification, the modules, and the reflector. We're now going to proceed to the build. This step writes the generated configuration to the active SvxLink configuration location. A configuration has been generated and I'm now going to launch it. SvxLink configuration has been built successfully and is active. I can now click on Open Dashboard. And this is our dashboard ready for use. There's one step to configure it in just a moment. And we'll do that by going to Authorize. Now with the dashboard user and password we created earlier, we now introduce more menus. And we haven't yet got any monitoring talk groups configured, so we'll add those. You can add up to 6. Any more than that, you'll be overloading your earbuds. So our first talk group 235 is UK wide, and we'll name it UK wide. And then we'll add 23561, and we'll call that one local. And we'll add 23562, and we'll call that engineering. And we save the monitoring talk groups, and we can now select the talk groups buttons for editing. Here we got 235, 2350, 23450, 23561, and 9990, which is a parrot channel. And you can change the colours off, and that one is showing as blue. We'll change it to green so it all complies. And we click on Save the talk groups. Buttons saved successfully. We can review our system from there. And we can go back. And we look at the log. It's generating log and it's connected to a service, and we've got connection established. For some reason or other, we've got an access denied. We'll sort that out in a moment, and that's probably just a local phenomenon which we shall check momentarily. We'll go back to the dashboard. Okay, we might not be happy with something, so we can go on rebuild. And we click on back. There's our review configuration. We go back again. And there's my password. You want to see my password. We want to enable Echolink, so we click on enable Echolink and continue. And we can put in our Echolink information in full with the password, sysop name and location. You are restricted to 17 characters, and square bracket SVX square bracket already has 5, so you're limited to 12 characters effectively. But we'll go back, and we'll go back, and we go back. We can go all the way back to the squelch method, even if we could have to change the squelch method. As it so happens, I don't need to change anything else, so I'll go to the top line and go back to status, which takes us back to the dashboard. As you can see, we've got a working dashboard. Everything's working except the connection, which I'll sort out momentarily. Right, having sorted out the niggles, which you will not have to face because the image shall have been updated by the time you play with this. The system is now running correctly. Now, there's a bit of better operation on this. We can now log out of our administration mode. So if you have exposed this as a dashboard for a repeater for your public, then you log out and they cannot then get into your dashboard to mess with it. However, we can actually change talk groups, so we can actually call various things and make them operational. So just testing one of these things, I'm going to turn my system to a local talk group 23561, and hopefully it will connect to that talk group. And yes, it does. And it turns the transmitter on briefly and then turns the transmitter off, having announced its presence on that talk group. And we want to disconnect. This is a simple one. We do 910 hash and send that. Brief moment of transmission. It turns it on, turns it off, just to say it's disconnected. All talk group reset. So there we have it. The repeater operation is identical. Obviously the settings will be different and there will be some times, the timer issues that you will need to sort out, but you can actually go back through that in the administration. So what have we here? A totally terminal-free environment. However, a couple of issues that might arise. If, for example, you've forgotten your password for the dashboard, not a problem, you can go and create another one. The instructions for that will be in the text below the video. You want to change the call sign of your unit because you've now got a GB7 or MB7 notification, or MB5 in the case of my repeater, in which case you can erase the current configuration, obtain a new password for your new device, and rebuild from the very beginning. That requires just a simple terminal control, one line command. There will be no configuration issues. You then come back to :5000 and rebuild your settings for a repeater. Okay, so we've got, thanks to Tobias, a new SvxLink version 26.05 to be precise. This is built from it now without exceptions. There are a couple of little minor issues, and this system that I have shown you will work on the UK-wide, North America and Australia networks. When I say UK-wide, that also includes the Yorkshire net reflector, which is tied in with the system in any case. Full credit to Tobias. Superb software, and it works very well indeed. The added advantage with this software is that we have provided for you in our network connections to the all-star talk groups that we find are most interesting, particularly Northwest All-Star Group, which we've assigned talk group 53573. For the United States, there's 9050, which is the East Coast Reflector, another very popular and very busy network. Also buried in there is the Ham Radio 2.0 channel, run by Jason K, and it also gives availability for that. And talk groups are selectable. RPD73, enjoy playing with the new SvxLink. This is me. Bye for now.